Hello everyone. Today we are going to be talking about matter, how matter changes, and how it affects our environment. And this is going to go under the learning target that students will observe how various objects can physically change over time involving a substance, how two different objects can change involving a substance, and students will determine how it is a physical change and how it can react to our environment. And this also goes under the standard. Students will be taught properties of matter and how to evaluate, communicate these changes. And so, what in the world am I even talking about? What is matter? So what is matter? And before I answer this question, I would like y'all to think about it, pause the video, think about how would you use this term in science. Let's say you're saying here these are these three types of matter. What is the context of this word? So what is matter? Matter is anything that has mass, which is how stuff in an object, and takes up space. So what could not classify as matter? I can tell you one, and that is light. Light is not matter because it doesn't have mass. It may have the characteristics of matter, in fact that it takes up space. You can take it light in a room, but it is not matter because it doesn't have mass. Alright, so together we are going to watch a short video that will explain more about matter and the phases of matter in depth. And then afterwards, we are going to do a little activity involved, and we're going to create an anchor chart that helps explain our how matter can change and how matter can change from one form to another at a molecular level. Alright, so keep your listening ears open, keep your eyes looking straight ahead, and put your hands in your lap. So we are about to get started with this, okay? Alright, and before we begin watching this video, I would like y'all to think about what can you predict on what this person would say about matter, and how would they use the definition of matter within this video and when describing different phases and different objects. Okay? So keep in mind with that question while we watch this video together. Alright?
Moo Math and Science. In this video, I'd like to talk about the different phases of matter. Matter normally exists as either a solid, a liquid, or a gas. We call this property of matter the phases of matter. The three normal phases of matter have unique characteristics. A solid holds its shape and has a fixed volume. A liquid takes the shape of the container and has a fixed volume. A gas takes the shape of the container but has the volume of the container. Matter can also change from one phase to another when heat or pressure are applied. When matter moves from one phase to another, this is considered a physical change. This triangle summarizes how matter can move from one phase to another. The plus and minus signs indicate if heat is added or subtracted. Let's first go over the changes that require heat. Melting is when you move from a solid to a liquid. This ice is a solid, but as heat is applied, it is slowly becoming a liquid. Evaporation is when you move from a liquid to a gas. As this water is heated, it is being converted to a gas. Sublimation is when a solid goes directly to a gas and skips the liquid phase. Underneath this smoke is a solid bar of dry ice. These next changes result when heat is removed. Freezing is when you go from a liquid to a solid. This snow at one time was a liquid, but as it cooled and became cold, it became a solid. Condensation is when you go from a gas to a liquid. When water vapor in the air hits a cold glass, it will slowly become a liquid. And finally, deposition is when you go from a gas to a solid. For example, this person is scraping ice on his windshield. The water vapor in the air went from a gas in the air to a solid on the glass. So I hope that helps with your understanding of the different phases of matter.
Alright, so we just got finished watching our video. What information did you gain from that video about matter that helped broaden your understanding of how matter works within different environments? So I need y'all to get out a notebook or a sketchbook if you have one, and we are going to make an anchor chart. You're going to make one of these, and this is going to be a whole lot of fun. And with your chart, you can use as many colors as you want. It doesn't really matter. And I find that mine you will be able to remember more if you make it colorful. Whereas I'm just using black Sharpie. So our first category is known as a solid. So what comes to your mind when you think of the word solid? Well, it might be rigid, it might be like round, but in our case, in science, we use the term solid to describe any object that has volume and shape. And y'all can draw some examples of what you believe a solid is. You can draw any example. There's no right or wrong interpretation. It's just how you can remember it. So what do we mean by volume and shape? Well, volume in science is termed as how much stuff an object can hold within it without it overflowing or erupting out. Think of it like a volcano. A volcano only has enough room for the lava to be in before it erupts. And like a container only has a certain amount of room before it will burst. So my example of a solid is going to be, can you guess? You might think a box or something, but no, it is a very weird looking ice cube. So an ice cube is a solid because it has a shape, which is supposed to be a square in this picture, and it also has volume because it can take up. It has enough space to where water can be encased inside it. And here is what it looks like. So what are these phases of matter? What are they made out of? Well, they are made out of atoms. And atoms are the structure, they are the building blocks for any object you can think of. Alright, so this is how atoms look like. If you were to look at it underneath a microscope, you see how they're all squished together. Well, that's because they have little energy to move around in that case. How do you think, when I use the term energy, I mean the ability to do work, to do any action possible. And so when we changed this solid into a liquid, how do you think, what are these atoms going to do? So as these atoms obtain energy, and energy can be obtained from any outside source. It can be from like environmental reasons. So in this case, we're going to use like the sun right here, the sun right there. It shoots some rays at the ice cube, and what it does, can you guess? It melts into a liquid. Alright, and that's my drawing for a liquid. You can use any drawing of water in this case. And the atoms, a liquid has no shape because it is wavy. And it is not the shape is not measurable. Some parts of it can be high and some parts can be low. And what we classify as having shape, it's a measurable object, measurable concept. So we put no shape. But it does have a volume. So when you pour a glass of water, that same object can hold that water, and it won't overflow, and you can measure it. Alright? So we do put volume right there. And the atoms, because they have more energy obtained from heat or other sources. Again, it doesn't have to be necessarily heat, but an increase in energy. They're going to look less squished together and further apart. See how they are? Well, these atoms within the liquid, they are further apart because why? Why are they further apart? Increase in energy. And what do you think? How do you think as this energy just builds and builds and builds and builds and builds? How do you think that is going to affect our atoms? Within matter. And so we keep adding energy. And eventually it turns into a gas. And a gas in this case would be water vapor. So I'm just going to put a cloud. And let me draw like a little raindrop for the liquid, for the liquid section. And so the gas, a gas is so small at this point that you cannot see it. You need a microscope in order to see the little particles. And the atoms at this point are so energized. They are going in their separate directions. They might bounce off one or two, but then they just fly back. And what situations would you see these changes occur within your environment? Maybe using prior information or prior experiences involved. And speaking of gas, the reason these atoms do this is because they have so much pent up energy, they have to go somewhere, so they just fly around. And the characteristics of a gas is that we're going back to our thing, is that while a solid has volume and shape, and a liquid has no shape but volume, a gas has neither, has no shape and no volume. So how do we measure gases? Well, we just see how much stuff it can take within a container, and then usually they just like compress it down and then measure it that way. But otherwise, you cannot really measure a gas. So how would you use these examples? How did you draw your examples? You can show that to your peers at a later date, or right now actually. You can pause the video and show them to your peers. So now we are going to I'm going to show you some physical changes in action right now, and changes of matter in action through the game I call Minecraft, which, if you haven't heard about it, it's a sandbox game that allows you pretty much to do whatever you want in it within reasonable nature. But it's an excellent way to show y'all changes of matter. And so before we start, can you think of any examples that any machines that you could create within this game that would show changes of matter? So like from like a solid to a liquid, or a liquid back to a solid, or a gas to a solid maybe? Who knows? Well, let's begin with that. So the first example I've got for y'all is I have, oh, that person just died. I have a blast furnace, and I got some wood here. So what do you think, and I got some iron here, and what do you think would happen when I place this iron in this blast furnace? How do you think it's going to change? So let's see. Let's see here. Oh, it changed from an iron to raw form to an iron ingot. And that is an example of what's called a physical change. So a physical change, like the term says, is physical. We can see it. And that a physical change is usually reversible, and it only goes from one form of matter to the other. So, for example, an ice cube can change from a solid to a liquid, but it can also change from a liquid to a solid and back. Alright, so like this ingot, if you did the opposite, and it's usually done by the opposite effects. So if you did it, instead of using a blast furnace, you froze it maybe, you could use it, you could reverse it back to its original form. And so, and when you see this example, what realistic examples can you think of like that this change would happen in? So for example, you could think of like a metalwork, that they would use metal all day long and they would try to smelt it into different stuff. So now we're going to this example, which I have lava right here. I've got a water bucket right here. What do you think is going to happen when I pour this water bucket down? Alright, so hang on, I need to get... Alright, I got a separate bucket because I know this is going to be messy, so let's see what will happen. Alright, and let's drop down. Oh, did you see the change? So this is also a physical change. Can you guess what the lava changed into? That's right, somebody probably said obsidian. Obsidian is basically just cooled lava, and it's a physical change because we can see the lava cooling down while it's also maintaining its original form. And it's still cooled lava, it's not a completely different object. Alright, and so our final example is, well, this one doesn't really have an active example right here, but can you think about like how this zombie used to be like, you know, and how this zombie can change by the flesh rotting off of him? What is that, a physical change? Can you think, and what properties or characteristics would that change happen? How would that change occur? And can you think of any like realistic situations you might have been in where you found a rotting animal maybe occur? Maybe? Well, like in this situation, in this game, this is a physical change. In realistic situations, this is probably known as a chemical change, which y'all can research that on your own. I'm not really getting into chemical changes right now. Alright. So that is it for our visualization model. So how do you think these models could be demonstrated in real life? Use your prior information with that. And we are going to transition to back over here because I've got some questions I need to ask y'all. Alright, so within our visualizations, we saw that matter can change into separate objects, and different objects have different traits or characteristics, and we call that physical properties in science. What do you think the importance is these models, these changes being showcased, and how do you think it would happen in real life? You can discuss these questions amongst your peers. Alright, so I need y'all to bring out your journal, your science journal, and as soon as everyone does this, I can answer or ask y'all some questions, and y'all can write it down and answer to the best of your ability. And this is up to your interpretation on how they may be answered. And don't forget to use evidence from what you learned during these activities. So like from your chart as a reference to what was shown in the visual models that we have. So, first question. Write down three statements that you have learned over this from the start to now about matter. So maybe you learned about like properties of matter, or the 3 different types, phases of matter, and how they can change. They can change differently. Maybe you learned about that. And question 2. Question 2 is name 2 instances that you would like to research more about and explain why. So, for example, you could want to know about if there are different, more than 3 types of matter, which I guarantee there are. And stuff like that. That would help you know more, research more about this type of science. And the 3rd question, 3rd and final, that one is have 1 question that you would like to know that was not answered in this lesson. So you could have a question about the types of physical changes, or how matter can have reactions to other matter. You never know. And later on, we're going to go back with these questions and these answers. Alright? So now we're going to do a lab simulation to see physical change in action. Alright? So first, before we gather our materials, I need you to pause the video and make a prediction on what will happen in this experiment. So in this experiment, will be involving salt, water, and either liquid alcohol or hydrogen peroxide. You can use either or, it doesn't matter. So what do you think will happen when the salt reacts to the water, when the salt reacts with the liquid hydrogen peroxide or liquid alcohol? Do you think it's going to be different or the same? Make your prediction. Make your prediction. And now we have to gather our supplies. So we'll need 2 cups. Make sure they're clear so you can see your reaction more clearly. Some table salt, some water at room temperature, about a cup full, and some liquid alcohol or hydrogen peroxide, whichever you have on hand. And for safety reasons, because this will involve liquids that can be harmful, we are going to be wearing a mask and gloves for safety reasons. We do not want to get hurt now. And before we get started with, there's another question I gotta ask, and that is, how do you think this experiment, what is the importance of this, what is the purpose of this experiment that you think? And it's up to your interpretation on that. Alright, pause the video, gather your supplies, and I'll be seeing you soon. Alright, everyone back. Okay, so we are going to put on our mask now. And we are going to put on our gloves now. And you always, I can't stress this enough, you always put on your safety gear before you do an experiment, alright? Not after and not in between. Alright, so now that we got our safety gear on, we can begin. Alright, so I have 2 cups of liquid, okay? One is water, and one is the hydrogen peroxide / liquid alcohol. So first, I want y'all to kind of, so see this one and see this one. So can you tell me what properties you can see, you can observe? What characteristics do you see within this? Can you tell any differences, any similarities between the two? Maybe? Write them down, document them, okay? Within a notebook or a sheet of paper, whichever one you have on hand. And you can also discuss with your peers on this too. Alright. So I've got that. And now we are going to take our table saw, and you can do this. Pour it in about a spoonful, and we're going to take one of these cups, and I'm guessing this one's the water, but I'm not really too sure, and we're going to pour it in, and then y'all can pour in a cup, and we're going to stir it in a few times. So can you see it? It's becoming a little bit cloudy now. Why do you think that happened? And you can see the salt's gone. Yep, the salt is completely gone. Why do you think this happened? What phase of matter did the salt change into? So now we're going to take another thing of salt, another spoonful of salt, and we are going to pour it into this cup. And we're going to see if the observations are similar, different, or whatever. And don't forget to document these too, okay? And y'all can document on your own, and you can do this experiment on your own too, and it'd be really fun. Alright, so we got that. Alright, we can see that while it's gotten a little bit cloudy, most, if not all, the salt is sticking on the sides and it's clumping together. You see? You see? So, did you get this result from your experiment? Maybe? Or did you get something different? How would I know? So now, you can clean yourself up if you want, or clean your work area if you want. It doesn't matter. Whew. That peroxide is strong, so be careful for that. And now we are going to go back to our desk, and we are going to evaluate our interpretations for how this experiment ended up, or at least I will. Y'all can talk to your peers and evaluate yourselves. Use those critical thinking skills to your purpose, okay? Alright, here we go. Alright, so you can see that the water did not really, the water did react to the salt. It dissolved it. The salt changed from a solid to a liquid. Whereas with the hydrogen peroxide / liquid alcohol, it did not change. The salt did not like that liquid at all. So what property do you think that would fall under? What can you think of? Is there a term commonly used within your environment that you would know of? Well, in my environment, this term would be known as absorbency. And absorbency is how much liquid an object can take. And it's either really absorbent, like the salt dissolving into water, or it is not at all absorbent, like the salt in the hydrogen peroxide. And sometimes and so that was an unusual event or a discrepant event. What discrepant event happened with your experiment? And do you think the changes that happened within our experiment, they were similar to each other or different? You can compare them with your peers. And what observations did you gain that were a physical change? Can you figure that out, maybe? So and at this point you should be making a conclusion about how that went up. And to me, my conclusion is that the salt dissolved into water. The salt changed from a solid to a liquid, whereas the liquid alcohol / hydrogen peroxide did not like. The water pretty much bounced off, or the salt bounced off pretty much of the hydrogen peroxide, and so it did not change from a solid to a liquid. It just stayed the same. And now that you've answered some of these questions or discussed some of these answers to these questions, do you think that what happened in your experience could happen in real life? Can you think of a situation you can showcase this to your peers within the class? So now, we're gonna play a review game, and before this, we do the review game. We would take out our laptops. We remove everything, including our anchor chart that we got right here, because we would want to know if we retained more of our information. So let's begin with that. And that game is Matter Sorter. It's on Brain Pop Junior, and it's a game about sorting different types of matter into different classifications. And y'all should know some of this matter. But maybe you don't know. Alright, so this game is called Matter Sorter. And the game, you see there's a solid, liquid, and gas, and there's also a type of matter called plasma. And while we didn't really discuss that, plasma, there's some objects that are made of plasma. And what does the word plasma sound like to you? How would you use this term in science? And how do you think this term would be used within a realistic situation? And so we were going to try to answer some of these, sort some of these objects into these categories, and plasma is just a bonus for y'all who are challengers out there. Y'all can attempt to categorize these objects. So now we start with milk, and what do you think? It's a liquid, right? Because it has no shape. It has shape, but it has no volume. Or it has volume, but it has no shape. So what do you think a flame is going to be? For example. Why, that is plasma. I'll give y'all that one. That one's plasma. And if you want to know more about plasma, you can research it on your own time. I'm not really going to go into that more in depth. Then it's an energy source, and it's a source of matter. Alright, oxygen, what do you think? Is it gas? Yep. And what do you think about helium? Helium is the type that we make balloons out of. So what do you think? It's that. And what do you think a solid is going to be like? You think a rock is going to be a solid? Yep. It sure is. Alright, so y'all are going to keep playing this game as long as until you can reach the next level or you run out of lives. So for example, this is what happens when you run out of lives. You lose a heart. And when you lose all the hearts, it's game over. So yeah, that's the fun in that. Alright, and then let's go straight to our assessment. And then I'll ask y'all a few questions about how y'all thought about that. So this is the phases and properties of matters assessment. And it goes into like situational questions on how phases of matter can happen in real life, and how y'all thought about your experiment as far, and other questions like this one: out of the available options, which is considered matter? Anything, and then remember the definition of matter. So A, rainbows, B, light. A, rainbows, B, light, C, a stuffed animal, D, all the above, and E, none of the above. What do you think it's gonna be like? And then, as you go further on, the questions are probably gonna be harder and harder. So like question 6, let's say you were gonna be skating on a pond, and you tested whether the ice would break by throwing a small stone. What change would occur? A, the ice melted, B, the stone broke through the ice, C, the ice cracked but not enough to break the ice, or D, no change happened. It is your job to think about how these situations would react and how to use that information in how to use your previous learned information to answer these questions. Alright, and then the last two, these are short answer questions, and the last one, this one's going to be up to your interpretation. There's no really right or wrong answer as long as you are in topic. Okay? So as long as you don't talk about something of absurd, that doesn't go into the topic of matter, physical change, and atoms, is basically a number, basically 100% right. So let's go back and let's review. But first of all, what do you think of the game? What objects did you not expect to be sorted within a certain phase of matter? And explain your reasoning. What question and what and y'all are going to be doing that assessment, or now, I guess. Y'all are going to be doing that assessment, and when y'all complete that assessment, what I would like to know, what questions on the assessment challenge you, and how would you adjust it to broaden your understanding on matter? Because I know some people, some people can be more challenged by some questions that may seem simple to others. So how would it help you to broaden your understanding on matter? Alright, so let's review. Let's go back to our learning target, and our learning standard. So our learning standard said that we would communicate, obtain, and apply information on how physical matter can change in various objects. So we saw that in our anchor chart that we got right here. And y'all do your examples right there. And we also saw it in our visual simulation and our lab simulation. Alright? And I want y'all to think about, like, what activity did you learn more from about matter, and why? How did you learn that? And did it alter your beliefs on how matter functions? Or did you not know about how matter functions at all? Alright? And then our learning target, which is we will determine how matter changes, whether it is a physical change, and how it reacts to our environment. We saw that in our lab simulation. Our lab simulation, we saw that a physical change can happen between a solid and a liquid, and that how it affects the atoms within our drawing activity, and how atoms, when they increase in temperature, they can increase in energy, they can either speed up and move really, really fast and separate from each other, or as it decreases energy, they can connect to each other and just stay still and not move, and that's what forms either a solid or a gas. Alright, so now you can pull out your journal again, and we can go back to those questions that you answered from earlier, and compare those answers to another student's. How were those answers the same or different, or likelihood have a likeness to each other? And read your peers. You can read your peers' answers, and how that, by reading that, helped expand your understanding on how phases of matter and how physical changes function and how they occur. And so now, if you haven't already, you can remove your unused materials from what happened during your experiment, from your workstations, and then now let's go into a second review. Alright, so we learned that matter is anything that has mass and takes up space. We learned that matter has three main causes, or not causes, but phases, and that is solid, liquid, and gas. And we also drew some examples of those phases within our handy dandy anchor chart. And we also saw how these phases are developed and made up, their characteristics of whether one has volume or shape or not, and how these atoms can change when given energy or when it removes energy. And we also saw from the simulation, the Minecraft simulation, how these changes can alter from object to object, and how different objects have different physical properties, how they can change differently but still remain that same object at its core. So, and then in our lab simulation, we learned that when you apply a substance to do different objects, that substance can cause different changes to react, different reactions to happen to different objects. Alright, so now I'll give you a few moments just to clear your head and to think about all of that. What did you learn? What is the activity that you learned the most from? And how does this activity, and I cannot forget here, within our and after that we did our simulation, our assessments. What is the assessment that challenged you the most? And if so, why is it? What is the reasons? Is that a good challenge, or did it frustrate you? You know, because as scientists, we are learning to discover, not to cause frustration among each other. All right. And from before, when you answered what activity did you learn about matter the most, and why? How did these activities alter your beliefs? How did they alter your beliefs in what you first thought? Because in science, we are always trying to discover new things, and how those new things can alter what we originally thought were true. And that is how different scientists even came up with the stuff that we know today, like gravity or electricity, and eventually matter. And maybe someday you can discover new things about matter that even I don't know about. So now that you've thought about this for a good few minutes now, we can get ready to, and when you answer these questions, we can get ready to and when you answer these questions, you can talk about these to your peers, or you can write about it. You know, whatever floats your boat with that. Alright, so that is pretty much all I have about matter and about physical change and physical properties that I had. If you want to if you want to ask some more questions, you can go down in the comments below and ask them. I'll be happy to answer to the best of my ability as a scientist. If you need more research on the subject, there are several books. You can go for books, videos, movies on the subject about matter. And because as scientists, again, we are always discovering new things, and we always want to challenge our beliefs. So when you go and research stuff, always think about how your beliefs could be challenged, including involving matter, especially involving matter. So, this is it. This is the end of this video, and I hope you enjoyed watching. You were engaged with this, and I'm sorry that my voice sounds a little bit hoarse because of weather changing. And okay, I'll leave y'all to it. Bye.